If a black hole is supposed to be a silent, frozen lump in space, how can we talk about it holding its breath and exhaling? In the energy filament theory, a black hole has a second layer called the piston layer, a ring of tensor muscle that really does move in and out and sets the whole object's breathing rhythm. In this picture, the black hole is not just a hard shell with a mystery inside. It is a 4-layer machine where the piston layer sits between the trembling outer skin and the boiling core. Matter and fields falling in from outside do not slam straight into the core stew. They hit the piston first. It behaves like a giant trampoline. When new stuff crashes down, the piston does not instantly fling it back into space. It swallows the impact, stores the push for a moment, then slowly hands that force inward or outward depending on the larger cycle. Deeper in, the steering core is boiling with energy filaments, constantly trying to push out. If that raw pressure went straight to the surface, the outer skin would be hammered like a drumhead under a bomb. Instead, the piston layer takes those surges, compresses them, stretches them out in time, and feeds them to the outer skin in manageable pulses. The result is a real breathing pattern, a slow in-out motion in tension space. You can think of the piston as a circular lung wrapped around the core. The core stew is like overheated air wanting to expand. The outer skin is like a soap film bubble drawn so tight it could pop. The piston in between inhales a bit of tension, exhales a bit, keeping the pressure swings from tearing the bubble in one catastrophic burst. A black hole's mood is written in this breathing. When the piston moves in long, deep strokes, the object looks calm and heavy. Its brightness and jets change slowly and smoothly, like a whale taking huge, measured breaths. When the piston falls into quick, shallow strokes, the whole system acts skittish. The brightness flickers, the jets stutter and surge, more like a small animal panting. Observers see these differences as different variability patterns and flared behaviors. But in this view, they are really watching the piston cycle. Without a piston layer, the shredding belt and stew core would punch their tension straight into the outer skin. The object would be like a sealed pressure cooker with its safety valves welded shut, doomed sooner or later to fail violently. With the piston, the black hole can eat, push, flare, and yet remain stable for a very long time, because there is always a buffer that catches each new shove and releases it on its own schedule. The piston layer is the black hole's muscle, its metronome, and its shock absorber. The reason it can be both wildly active inside and deceptively quiet on the outside without simply blowing itself apart. In the next episode, we will drop one step lower, into the shredding belt, and ask why anything that crosses that zone looks as if it has been fed into the most extreme blenders in the universe and pulled apart into filaments. Tap follow, share it on New Physics, Clear Universe.